you're a data analyst, or you want to become a data analyst. You are diving deeper into the complexities of SQL, and most likely, you encountered a common data challenge. How do you retrieve specific information that requires multiple layers of data calculation, filtering, or manipulation? How do you navigate this vast seas of data without getting lost in the details of running redundant queries that slow down your analysis? So, I'll bring you a new tool in your SQL arsenal, the SubQuery. Hey there, I'm Ievgen. You're at our OWOX BI YouTube channel where we speak all things about analytics, data, SQL, sometimes a bit of marketing, data warehouses like bigquery, and spreadsheets. Here, we empower you as a data person as well as your business teams to use the power of data to grow faster. Don't forget to hit that subscribe button and turn on notifications. You won't want to miss our next videos on this channel. With this being said, let's jump right in and demystify the subqueries together. Alright, let's talk about subqueries in SQL, sometimes also referred to as inner queries or nested queries, which are basically queries within a query. It's an SQL query embedded within the outer query. A subquery is a way to perform operations that usually require more than one step in a single query. It's like having a conversation where the question leads to another question before you get an answer. It's used for database operations, where the result of one query depends on the data returned from another query. There are a few different types of subqueries. 1. There are the single-row subqueries. Those return just one row, not because they are simple. This type of subqueries is typically used when you are making simple comparisons using operators like equals, greater than, or less than. 2. There are multi-row subqueries. This can return multiple rows and are great when you want to compare against a list of values. You'll use this type of subqueries with operators like in, exists, any, or all. I'll provide more real-life examples going forward, so keep watching this video. Next, number 3. Correlated subqueries. They are a bit more complex. They rely on information from the outer query, recalculating results row by row. And finally, scalar subqueries, which return a single value like an average or maximum, and can be placed wherever you can use a single value in SQL. Using subqueries allows you to handle complicated data retrieval tasks from within a single SQL statement. They make it possible to encapsulate detailed filtering or aggregation logic, simplifying interactions with the database and keeping your data manipulation clean and efficient. Now, let's dive into how subqueries work in practice by exploring some common scenarios where they are used in SQL operations. We will start with a very simple example. Imagine you want to find out which products have a price above the average in your database. You could use a multi-row subquery in a select statement like this. So you select the product details like ID, name, price from the products table. But then you apply subquery in the where statement to calculate the average price. This query uses a subquery to calculate the average price across all products. So then it is passed back to the original query to find the products that exceeds this average price. Let's make our task a bit more complicated. Imagine you are analyzing data from a sales database again, the same one. You want to identify products that are priced above the average. Again average, but not across all products but only within their category. Here's how you might use a multi-row subquery to accomplish this. This query selects product IDs and names and their prices from the products table. This subquery then calculates the average price of products for each category. The outer query then uses this average price to filter and list only those products whose price exceeds the average in their respective category. This demonstrates the power of a subquery to perform complex comparisons that involve group-specific calculations. Next, let me showcase a single-row subquery here. Suppose you need to find the most expensive product within each category. Here is how you'd structure that query. So here we select the product ID, name, and price from the products table. The subquery calculates the maximum price for each category, and the outer query fetches the products that match this maximum price. This example showcases how a subquery is used to fetch a precise value that affects the output of the outer query. Now, let me demonstrate a correlated subquery. As you remember, a correlated subquery relies on values from the outer query. In this query, we look for products where another product exists in the same category with a higher price. Essentially, it lists all products except those that are the most expensive in their category. The exists statement with a correlated subquery helps filter rows based on the existence of other rows. Finally, consider a Scalar subquery. This one is used to display the average price of all products alongside each product for a comparison. That's also the one where a subquery is used as a part of the select statement, not the where statement as the previous ones. This query retrieves each product ID, name and price, and includes the overall average price calculated by the Scalar subquery. This Scalar subquery is executed once, and the result is repeated across all outputs, allowing for easy comparisons of each product's price to the overall average. Here's how you can modify the query to also retrieve the average price for each product within its category, with the results ordered by category and then by the product name. This enhanced query still retrieves each product ID, name, price, and category, but it now also includes the average price of all products within the same category. The results are sorted first by category to group products accordingly, and then by name to order them alphabetically within each category. Now let's see how subqueries can be effectively used in the from clause. Suppose we want to analyze the performance of products by comparing individual sales to the average sales in their category. Here is how we could write this query. Look how I've placed the subquery with the select, from, and group by statement inside the main query. Then, another subquery calculating the average sales by category and joining it back to the list of products. All these examples utilize the structure of a typical e-commerce store database, emphasizing how subqueries can be effectively used to extract detailed information and perform complex data comparisons. When you have a large database, subqueries basically significantly enhance the capabilities of queries, allowing you for intricate data manipulations within a single query. This flexibility that you get makes it easier to perform complex conditional evaluations, aggregate functions across different data segments in specific, and compare data subsets directly within the database without running multiple query statements one by one. But on the flip side of things, subqueries can impact query performance, particularly if they are not well optimized or involve processing very large datasets. Each subquery may require full execution of the inner query for every row of the outer query, leading to increased computational overhead. Let me give you a few of the most important tips to remember when using subqueries. Tip number 1. Implement where clauses within your subquery to narrow down the data as soon as possible. This reduces the amount of data the database engine needs to process in the large stages of the query execution, making the query more efficient. Next, indexing. Apply indexes on columns that are frequently used in subqueries, especially those involved in joins, because that can drastically speed your query performance. Indexes help the database quickly locate and retrieve the data without scanning the entire table. Tip number 3. While nested subqueries can be powerful, they can also lead to complex execution paths that are hard for the database engines. Try to flatten queries where possible or replace nested subqueries with joins or temporary tables. And this nicely leads us to the next tip. Often, a join can be more efficient than a subquery, particularly when dealing with relationships that involve matching multiple rows or tables. That is because joins are generally faster and more scalable on large databases. If you want to learn more about joins and unions in the context of databases, here is the video that we've recorded. That's it. By following these tips, you can make sure that your subqueries are not only useful but also perform effectively and not leads to overexpenses. And there you have it. We ventured deep into subqueries in SQL today, discussed their role in crafting queries faster, from the basics of single rows and scalar types to more advanced multi-row and correlated subqueries. We've explored many real-life examples, tips, tricks to make your queries smarter. Remember, mastering SQL and subqueries in specific really involve just one thing: practice. Try using subqueries when performing SQL tasks to see how they enhance your data retrievals and manipulations. If you find this video helpful, please give me a thumbs up, share your SQL experience in the comments down below. We love learning from your use cases, applications, and challenges. Don't forget to subscribe and hit that notification bell to stay updated on all of our latest tutorials designed to empower your analytics journey. Thanks for watching this video. I'm Ievgen from OWOX. We're here so you can dive into the next data challenge with more confidence. And remember, every query is a step towards mastering SQL. So keep pushing the boundaries of what you can do with your data. Stay curious, stay analytical, and as always, happy querying!